And so hyperbolas are very similar to ellipses. So it's all kind of a progress and transgression between circles to ellipses to hyperbolas. The similarities are all there between them. But for hyperbolas, instead of a major axis and minor axis, it's a transverse axis, which is this one between the vertices, and a conjugate axis, which is this one here. Now, this will make basically a box that passes through the vertices and the co-vertices that basically connect the conjugate axis. There's these asymptotes here that cut through the center and the corners of that box. Notice that they're hitting the corner of the box, and that will give you how wide or narrow the hyperbolas are. But those are asymptotes, which is why the hyperbolas take the shape that it is. And they also have two foci as well, but they're inside each part of the hyperbola, very similar to a parabola. So you have the vertices, which are the endpoints of the transverse axis, or that major axis hitting the vertices, and the co-vertices are the endpoints of the conjugate axis. Because this is subtraction, it does make a difference which variable comes first. If the x is first, it makes it horizontal. And if the y is first, it makes it vertical. So horizontal, they're going to be going like this, and vertical, they're going to be going like that. And the foci are at plus or minus C0 and 0 plus or minus C based on horizontal or vertical. It's basically the C, again, is the distance away from the center. The length of the transverse axis is 2a. In either one, notice the a is always under that first variable. And the length of the conjugate axis is 2b. The asymptotes are going to be y equals either b over a times x or y equals a over b times x, and both positive and negative to get both asymptotes. It's basically the denominator on the y over the denominator on the x. You still get your rise over run, but the y is going to be in the top. The denominator from the x is going to be on the bottom, which is why that a and b switched, because in the formula for the horizontal and vertical, the a's and b's switched. So show how to write an equation for the hyperbola shown. Well, I want to know here my center is going to be 0, 0, because that's halfway between the two vertices. I don't know the b in this case. I don't see that box, and I don't know where that box is in order to get to this, but I can find the box because I also do know the c. So my a is 2, basically the distance from the center to one of the vertices, and my c is 4, the distance from the center to one of the foci. In this one, though, the equation is going to be c squared is equal to a squared plus b squared. So in this case, I get 16 is equal to 4 plus b squared. And when I subtract 4, b squared is equal to 12. If I'm looking for b, I take the square root, and b is equal to the square root of 12, which is approximately 3.5. So a few things you got to pay attention to. One, it is hyperbola, so it's going to be, you got the two fractions, and it's minus in between, and they're equal to 1. 2, it's going vertical, which means my y squared is going to be first, and then my x squared. And now I got to find the a and the b. Well, the a is 2, so that's going to be here, but it's going to be a squared, which is 4, and that's going to be the first denominator, and the b is the second denominator, and b squared is what I want, which is 12. And that's it. That's my equation. So for this next one, it's giving me the asymptotes and the vertices, and I'm trying to write the equation. Well, because it gave me the asymptotes, I basically have that a and b. I just need to know which one's going to go first, and I can tell that from the vertices. The vertices are at 0, 3, and 0, -3. Because those are the vertices, means that the graphs are opening up like this, which means it is vertical, so my y is going to be first. And because it's a hyperbola, I have a minus, and again, it's always equal to 1. So under my y is going to be this numerator. That's my a. A is equal to 3. B is equal to 4. So that means under the y squared is going to be a squared, which becomes 9. Under the x is going to be my b squared, which is 16. And if all I'm looking for is the equation, then that's it. So now it's going to be shifted, and it's still you have your h and k. The h is inside with the x, the k is inside with the y. So when the x is first, it's still horizontal. When the y is still first, it's still vertical. So the x is first, it's still horizontal. The y is first, it's still vertical. Your foci are still c away from the center. It's just if that's horizontal, that c is going to be added to the h. If it's vertical, the c is going to be added or subtracted to the k. The vertices are a away from the center. It's just if it's horizontal, that a is going to be added to the h. The vertical, the a is added and subtracted to the k. And the co-vertices are b away from the center, based off of which direction. So the opposite of what it is. So if it's horizontal, the b is added to the k going in the vertical direction, and in a vertical one, the b is added to the h. Don't get frustrated with this equation. The equation is still the slope of a over b or b over a for the asymptotes. They're just from the center. You can still just graph it from wherever the center is, and you just use the slope a over b or b over a. You don't need to find the exact asymptote. So for this one, show how to graph this equation, identify the vertices, foci, and asymptotes. Well, I like to identify all the parts first. My center is at, remember we're using the opposite of these, so the x is 3, the y is -5, so I have my center at 3, -5. The a, which is going to be under the x, is 2, the square root of that, remember, and the b is 9. So I have the center at 3, -5. This is a horizontal, so my vertices are going to be 2 away from that in the x direction. And my co-vertices are going to be, the b is not 9, the b is 3, the square root of 9. So the b is going to be 3 away in the vertical direction. And I can make that box now like this. And from the center, the asymptotes are going to be using a slope at 3 over 2. So I have this here, 1, 2, 3 over 1, 2. And I'm going to draw it all the way to the end. And here. So I have my asymptotes going through that box in the corners and through the center. And to find the foci, I need that equation c squared is equal to a squared plus b squared in this case. So I have c squared is equal to 4 plus 9. C squared is equal to 13, so C is equal to square root of 13, which is going to be approximately 3.6. So that's going to be 3.6 away from the center though, so that's 1, 2, 3.6, and 1, 2, 3.6. So if I'm looking for those points, this is at 3, negative 5, and I'm adding it to the y and subtracting it from the y. So I have the foci at 3, and when I do negative 3 plus 3.6, and when I do negative 5 plus 3.6, I get negative 1.4, and then when I do negative 5 minus 3.6, I get negative 8.6, and those are my two foci. So when I do the foci, remember this is horizontal, so it's going in the x direction, 3.6 in both directions, 1, 2, 3.6, and 1, 2, 3.6. And then my graph goes like this around those foci. To find the foci, I'm taking this 3.5, the center, and because I went in the x direction, I'm adding that 3.6 to the x and subtracting it from the x. So I get 3 plus 3.6 and 3 minus 3.6. Well, this one becomes 6.6 and this one becomes negative 0.6. So my foci are at 6.6, negative 5, and negative 0.6, negative 5. The y value stays the same as the center. And we had already found the vertices, which were at negative 1, negative 5, and 5, negative 5. I'm not going to have you write the equation for the asymptotes. As long as you just draw it correctly using the box, that's fine. So go ahead and pause this for a second and try these two on your own. So for the first one, the A is going to be 9. The B is going to be 7. I know this is a horizontal because it's telling me the vertices are at 9, 0, which is over here, and negative 9, 0, which is over here, which makes the center at the origin, or 0, 0. So it's going out this way, and which means the x is going to be first. The denominator is always going to be the denominator of the asymptotes is always going to be under the x. The numerator is always going to be under the y. And that's it. And you make it minus because it's a hyperbola and always equal to 1. And this is the graph of the last one, the hyperbola. The vertices are at 4, 0, 4, 6. The foci, I had to find the c here, which is square root of 34, which is approximately 5.8. Which then I added to the y value because this is a vertical, because my y is first. So I add that to the y value of the center and got for 8.8 and for negative 2.8. And I actually am just going to have you find the slope of the asymptotes, not the whole line, just the slope, which is plus or minus 3 over 5. Rise 1, 2, 3 over 1, 2, 3, 4, 5, and that's it. Why couldn't the monkey catch the banana? Because the banana split. Banana split. He said, I'm out of here.